Hello everyone, today we'll solve interesting problem. Okay, concepts covered Coulomb's law, Newton's second law, and differentiation. In our problem, we have two identical small spheres, each of mass m and initial charges q0, suspended by long light strings of length L. Initially, the spheres repel each other due to their same charges, creating a small separation x. Over time, the charge leaks from spheres following equation. Q equals Q 0 times 1 times the quantity 1 minus t raised to the power of 3 halves, where a is a constant related to charge leakage rate. As the charge decreases, the electrostatic repulsion weakens, and the spheres gradually move closer. And then we have to find velocity. And we find velocity by taking the derivative from our small separation. But we don't know our small separation. We don't have it. And we will find it by using Newton's second law and Coulomb's law. Uh, you know, each sphere experiences three forces. Let's look at them in a coordinate system. So it's our coordinate system. As you see, sphere experiences three forces. First, it's gravity acting downward, mg, tension along the string, and the electrostatic force acting horizontally. Now, and also tension acting along the string. That's why we need projections, and we take the tension projections ty and tx. Now, let's write general formula of our Newton's second law. So our net force equals mg plus electrostatical force plus tension, it equals 0. Now let's write net force for y-axis. Net force. So in y-axis it's acting mg and ty tension. M oh, mg plus t tension equals 0. Don't forget that all vectors. Now let's write it with signs. So mg acting downwards, that's why its signs will be minus g, then it will be plus tension y equals 0. And our t y equals mg. Now let's write net force acting on x-axis. So in our x-axis acts electrical force and tension force. Projection of tension force is Tx. So let's write formula x equals 0. Now let's write it with signs. So as we see, electric statical force will be with minus sign, and our Tx will be plus, and it equals 0. So our tension force acting on x-axis equals electrostatical force. Yep. So That's we need. Now, uh, we have angle here and tangents alpha equals t x equal over t y. We don't know tangents alpha. Let's find it from here. So the total angle between the strings it's 2 alpha, but each string tilts by the same amount from the vertical. Uh, so we use the half angle alpha. So the triangle formed by a string, a vertical axis, and a half the separation. Uh, Equation help us derive the equation efficiently. So here we can find our tangents alpha. Here our tangents alpha equals x over 2L. Yep. So now we know our tangents alpha. Let's put it here. So we know our tangents alpha equals tx over ty ty. I'm sorry. Equals x over 2L. So, and we know that our tangent force acting on x-axis equals electrical force, and we know that our electrical force equal k q square over x square. So let's write it. So I said it's F electrical force and our tangent force acting on y-axis equals mg. So electrical force over mg equals x over 2L. And we know our electrical force, it's q square mg. I'm sorry, it will be mg multiplied x equals x over 2L. Also, we know our q, our touch, it's given. Let's write it. And it's square of touch. So I will write it like that. Q0 square multiplied 1 minus 8t power of 1 over no, it will be that's a 3 uh, over mg x squared equals x to L. It's x. Now let's find x here. X will be power of 3 equals mg to L chi q 0 square 1 minus a c 3. Now let's find x. It will be mg to L q0 square multiply it will be power 1 over 3. Then it will multiply it. 1 minus a, perfect, a, a, t. Yeah. Then, as I said, we will find velocity by taking the derivative from our separation. So, we will not take a derivative from that part because our L, Q0, M, G, M is set and K and G it's constant. So it will be constant, and we will take derivative from that equation. So 2L Q0 square M G and over 3 multiplied 1 minus a dip, it will be, oh my god, M G. Oh, no, it's not 2, it's actually 3 and over 3 multiplied. So when we take derivative from this, it will be 0, it will be a. So minus a. We'll take derivative uh, by time. That's why it will be minus a, and it's our final answer. It's our velocity, and it's the negative sign indicates the spheres are moving toward each other. So thank you. Goodbye.